We are continuing solving our task, and the next task will be the following one. It's find the safest path in a grid. You are given a 0 indexes 2D matrix grid, where each cell represents a chief with 1 or an empty cell with 0. We are starting at initial position, and we can move to any adjacent cell. The safest vector of a path on the grid is defined as a minimum Manhattan distance from any cell in the path to any chief in the grid. So it's actually our safest factor. We have to return the maximum safest factor of all passes leading to cell, and return the maximum safest factor of all passes leading to cell n-1 and n-1. So okay. Okay. And it's about adjacency sets, and it's about Manhattan distance between two cells. So AB and XY is equal to A minus X plus B minus Y, where well denotes the absolute value. So here we see that we see 1 here and 1 here, so we never can reach, we don't have safest road. So we just return 0. Here we have this one, for example, or this one. So the path depicted in the picture above has a safest factor of 2, since the closest set of the paths to achieve is the set 0, 0. The distance between them is 2. It can be shown that there are no other paths with higher safest factor. All right, great. So let's first think about this question. So we are given a grid with cells 0 and 1. And our task is to find safe passes. So here we can see that we have this pass, this pass, this pass, this pass, so a lot of different passes. So to calculate actually these passes, we can use a BFS function. And with BFS function, we may calculate for each cell where we now standing the safest value. By safest value, I mean the maximum value yes, the maximum value would be not work, I think, because I have another values. So in one hand I have chiefs on each position, and on other hand I have passes. So first of all, I'm interested in what the ranges of my grid. And the ranges is from 1 to 400. And if it's 400, I have 40,000 cells. Okay, and for 40,000 cells, I may generate some passes, and this would be really hard way to do. I mean, not hard, but we still need to store these passes and then to go through each chiefs and calculate the safest factor for them. So here we may go like this. Yeah, so it would be always, the safest would be always, why it's 2? Because here I have 1. Okay, so the closest cell of the path to achieve, cell 0, 3, so this one, is cell 1, 2. Yes, this one. This distance between them is 0 minus 1 plus 3 minus 2. It's 2. Okay. The closest cell of the path to the chief at 3 is a cell 3, 2, and the distance between them is also 2. Three, 2, this one. Okay. Okay, interesting. So let's think what can we do? Can we like store all chiefs and yeah, we can try to, what can we do? Yeah, because let's draw some examples. So for example, we have something like this. Yeah, we have something like this. So we have chief that the closest path is actually 0. But how do we know that it would be a path? Because for instance, we can go here and then here, then the closest path would be this one. But still, if we have like this, then we go here, we go here, we can go here. So we don't know actually this path. And what if we again have more zeros like this? Then I go here and go here, go here, go here, go here, go here, and I don't have this 0. Yeah, so how can I calculate in this way? So I have this once. Here I can calculate all passes. Okay, it's interesting. Okay, let's consider using BFS and binary search together. Okay, so I have BFS and I go, yeah, I can create an array process for each cell I can find with binary search. Okay. Okay, launch BFS starting from all cells containing chiefs to calculate which is the smallest Manhattan distance from X to Y to the nearest grid that contains chief. Okay. So here I can calculate what is the distance for this passes. Then for this passes, yeah, so I can start BFS from these both sides. So for example, I can start with this one. Then for every cell, I can calculate with BFS again. So here it would be +1, 2, 2, and 2. Here it would be 2, 2, 2. Then here it's 3, 3, 3. Here 2, here 3. Okay, I can do something like this. So I may update this grid. And what then? So I start with 2. Then I can go to smallest. Then again 2, 2, 1, 2, 3, 2, and 3. Yeah, but I have 3 here. Okay, and what next? To check if the bottom right cell of the grid can be reached through the path of the safest factor V, eliminate all cells such that still connected, there exists a path between 0 of the safest factor V. Okay, and once again. So we consider using BFS and binary search. We are launching BFS starting from all cells containing chiefs and calculate each cell which is smallest Manhattan distance from XY to the nearest grid that contains chiefs. So we calculate. To check if the bottom right cell of the grid can be reached through a path of safeness factor V, eliminate all cells such that grid XY less than V. If 0, 0 and are still connected, there exists a path of safest factor V. Yeah, but how can I know the safest factor V? Actually. binary of the final safest factory. Um, hmm. So here I have 3. So this one, this 0, 0. Here I calculate like 1, 2, 3. So here 3, 3. But yeah, I have something closer. Closer. So here, yeah, it would be 3. This one is 2. 1, 2. 2. Here is 3. 2. Yeah, it's 3, 3. Here is 2. This one is 1. Oh no, this one is 2. Yeah, so I start with 2, then go to 3, then I go to 2, then to 3. Here I can go to 2, here to 2, here to 3, 2 and 3. So what can I do here is when I calculate this grid, then I try to go to the maximum element of my path. So here I check all my adjacents and go to the maximum. Here I have 2 and 2. So in this case, I'm go both to 2 and 2. Then I go to 3 here. From 3 again, I go to both. Here I go to 3, go to 2 and to 3. And from all this path, I return the. So I go to maximum, but I return minimum. Yeah. Let's check maybe a tutorial. How it would work. Okay, so okay, so this one we calculated. Yeah, so this one we know. What next? Okay, let's check directions, BFS. Push chiefs contained to the queue. Okay. Then, yeah, so we are doing this calculation and binary search for maximum safety factor. So how it works? So we start at 0, 0, and not and Okay. Yeah, so it's quite complex one. We can use BFS to compute the safest factor for each cell in the grid. This is how the result grid look for the third example. Yeah. So we have 4, 3, 4, 3, 4, 3, 4. Yeah. So there we can run Dijkstra from 0, 0, finding the path to the target with the maximum safeness. Yeah, so I actually have the same idea. So we reuse the input grid to populate safest BFS and mark visited nodes. All right. So here is BFS. Then priority queue. And yeah. Okay. Okay, so I didn't solve it. Thank you.